this weekend. Okay.
Yeah, we can.
Yeah.
Go ahead.
Okay. Yeah. Just let me introduce myself. Uh, I think Shannon has already introduced me, but a little bit more about me. So my name is Jiten Malpati. I have around 17 years of experience. Started my career with C++, and over the period of time, I am catching up with the new technologies. It will be, working on heterogeneous applications, working on uh, pure low-level backend systems, working on operating systems, related low-level kernels, microservice architectures, working on cloud-native computing, and then for the fun, then started working on agentic AI, basically machine learning algorithms. And for the past 2 3 years, I've been extensively working on AI, Gen AI, and then obviously the agentic AI. So this particular presentation is a webinar, so definitely we cannot go through very in-depth of uh, anything. Just would like to give you the overview of things. That way you understand that at a pretty high level. So I'm just setting up the expectations because I don't think that this 1 hour you are going to know everything or you're going to know. You will have some high level idea about uh, what this training is going to be, what this particular webinar is going to be about. So the whole concept is mastering AI, mastering AI engineering. Obviously, it is an engineering. It's part of engineering domain. We will look into LLMs, uh, racks, which is very popular nowadays. In order to work with racks and then agentic AI, there is a LandGraph, line chain kind of a components of it. That's what I'm going to discuss. We are going to discuss obviously. Okay. Just now, I think just before this call, just trying to create the content. Somebody has called me, one of my friends. His son is working on he's into environment science. He's into environment science. So he called me that he asked me, Jitin, do you know anybody who can, help my son? Because they did a startup, okay, from USA, and then they are working from Kochi, and then I think from US and Kochi, they are writing some journals, they are working on environment. Do you know anyone who can work with them to scrape some data and then uh, definitely generate some data and then give to them? Data is valid data. That is one case. Just before that, I think a week ago, I was speaking to one of my friends uh, who is from Mangalore. He has almost 10, 20 years of experience in developing software for the trading. They are the back-end actually software providers. Whatever you see, Zerodha, Angel Brokers, Substack, like that's 90% of the stock companies they run from. Actually, they are originated from Mangalore. Mangalore is a hub for two things. One is ice cream, and the second thing is stock markets. Yeah, their head offices are in Mumbai, but yet that they're all started from Mangalore. He was asking, what do you think about doing some quanta based trading where we use some kind of a trained models and then we try to bring some kind of agents where instead of humans, the agents would try to do the trading. Obviously with some guardrails, with some rules. Yeah, because it's with money. Even couple of days back, okay, my wife, she herself is a doctor working in radiology. She went for a conference and then they taught her how to work with Python and how to work with models. So if you really look at the surface of where AI is getting into, evolving into, is vast. Okay, there is no field that which is not related to AI. Particularly the data, wherever there is data, there is AI.
Jitin, excuse me, sorry to interrupt you. You're not, your voice is breaking in between, and although it's not so clear also. So,
Is it for everyone? Is it like that? For everyone is it okay? Yes,
Yeah, I put the Mac. However, I'm not able to fully hear you.
you're not able to hear me.
Yeah, yeah.
Give me a moment. It's,
There is some disturbance. That's the reason.
yeah, it's good. Heavily raining outside. They might be catching up that sound. There could be a chance. Give me a moment. I hope it is comparatively okay.
Yeah. Okay.
Yeah,
Yeah, it's okay. It's okay.
it's okay. So AI is everywhere actually. You see that whatever the field that you talk nowadays, AI is everywhere. And who has to learn AI? Everybody has to learn AI. It's not confined only to software engineers. It's not only for software engineers has to learn AI. AI is everywhere and everybody has to learn AI. Like how MS Office and tools people used to learn. And then every sector there are people are using MS Office. Similarly, the AI is going to be. But what is the specialty that software engineers, especially software engineers, what is the when you try to uh, bifurcate it, people who are using AI, I don't think that we need to say today. I don't need to say that okay, how to use GPTs. Everybody is well versed with GPTs. But if I ask how GPTs work, I think many only technologists who already invested a lot of their time can explain how GPTs work. So like that, AI is everywhere. Everybody is using AI. Python has become a calculator for many professions. Okay, but with respect to the engineering discipline, understanding how AI works, how to connect different AIs, how to work with your customized data or the data that belongs to the proprietary data along with the generative AI like LLMs, large language models. It's where exactly the engineering discipline come into the picture. It's not like using AI. It's all about, you know, how do you drive AI agents? How do you create AI agents? How do you engineer them? How do you connect different components and get them to work so that a complete end-to-end solution with respect to AI can be obtained? We, from the engineering discipline is what actually we are going to discuss. Okay, so that's where LLMs and then agentic AI. This particular webinar is part of what actually is from here. It's a part of this. We are going to discuss at least a webinar for a few minutes. LLMs and then agentic AI webinar. Okay, so you might have heard a lot of large language models. LLMs is very popular word. Okay, GPTs, llamas, LLMs, Claude, ChatGPT. Okay, Google Gemini. Cursor, particularly you are into software, and then Cursor it has become very famous, particularly for the software engineers. All these things have become, a regular keywords or buzzwords nowadays. The industry is talking about. Many people are talking about. So, what exactly the large language model? A model that has been trained on billions of parameters. The parameters. Parameters is if you take a basic expression y equal to mx plus c, basically the original training will go in depth of little bit of mathematics, but at least for this webinar, I just would like to give one or two basics of mathematics. Not going in depth, but at least I would like to highlight. If you say y equal to mx plus b, so that means there is a dependent variable and then independent variable. You are going to find out the value of I by mx plus pc or mx plus b. Many people have different notation, but the formula is same. There are two parameters which is called x and y, and then you are going to provide a solution. Particularly if you really look at the uh, two-dimensional coordinate geometry, which we call it as a plane. Okay, there is the x axis and then y-axis. We can call them as two parameters. So large language models are trained. That means they trained on billions of parameters. So billions of parameters means they trained from whatever the data that is openly available, archive files, maybe from Wikipedia, maybe from whatever we have been thinking all these years that it is free, Gmail is free, photos that you can upload is free. Okay, audio files like are free, whatever you are talking about, anything is free. Actually, nothing is free, particularly the data is not free. Most probably, most of the data that is being used, which is publicly available, is being used to train the models. Ultimately, this data would be mathematically, they try to convert this data in the form of vectors. You know the vector? Maybe in the your school based on mathematics, there are vectors, there are matrices, okay, there are scalars. Ultimately, it's called as a vector. So vectors are nothing but parameters. The large language models are trained on billions of vectors. You can understand billions of vectors. Okay. They how they work is it's all token based. Token based means whenever you type something in any GPT, it would convert your text into tokens. Obviously, the tokens would become a token embeddings. There is a model that would work on token embeddings, and ultimately it would be formed as a vector. And then this particular vector is trained, okay, in order to generate the data. That's what exactly the GPT models do that. Okay. So again, I'm just giving very high level information. Uh, I want you to know a little bit of it. At the same time, we have to proceed further as well within the given stipulated amount of time. Okay. So uh, that's what actually the probabilistic next token prediction. Ultimately, whenever you are saying that hi, what is your the probability of that hi, what is your is the probability might be name. What is your hi? What is your name? How are you? The probability would be doing. So how do they calculate the probability within the billions of parameters? Okay, they calculate the probability by an algorithm which is called attention is all you need. Okay, that's an algorithm. It's an algorithm. It's a white paper that's what written by Google in I think 2016 or 17. That's where exactly the whole thing works. So there is a deep neural architectures. So they used a architecture called transformer architecture. Okay, basic neural networks. Earlier, if you work on text, it used to work only on text. But if you really look at LLMs, LLMs would work on embeddings. Embeddings are nothing but numbers, right? Neural networks earlier, the RNNs, I think they call it as RNNs. They all work on actually the text, but they found it a lot of problems with that. Okay, they created a transformer architecture. How many layers of transformer means you know that there is a there is something called encoding and decoding. There is something called replacing something with something else. It's a layers of transformers. Okay, hundreds of layers of transformers. If you take, I think the current GPT, latest versions of GPT, latest one for Gemini, and all they all work on transformer architecture. Transformer is nothing but maybe you tried something, there is a spelling mistake, even still GPT can able to understand that there is a spelling mistake and it can auto correct it and then give you the answer. Because there is a layer, maybe one or two or many transformer layers that would go and then understand that, yeah, whatever the text, whatever the prompt that you give, it might be having a wrong spelling itself. So it would go and then correct in order to proceed it further, in order to generate the test. What it does is it goes and then one of the layers of this transformer architecture will go and then correct the spelling. Okay. So it has got reasoning capabilities. How it has got reasoning capabilities? Definitely whatever you have texted earlier, let us say that you log in into GPT, okay, immediately GPT says that, hi Jitin, how are you doing? Okay. If you keep on asking GPT for some questions, there is a session, every window that you open is a session, and then it can understand that, okay, previously you were asking about Python or you were asking about Go language. I think you know that you are expert in Go language. Let me go and then give you some kind of details about that. So how does it know? It can reason out. It has got the context. They call it as a context. It has got the memory that it can learn from the context, whatever you have typed earlier. These kind of capabilities it has got, it can reason out from the previous context. These are all evolved over the period of time. Nothing has happened within a year, but we start using LLMs, sorry, GPTs, LLMs, etc. recently, but it is a work of actually maybe decades. It is not evolved over, I mean, overnight or in 1 year or in 2 years. The work happened over the decades. Google themselves has done the paper, attention is all you need. It took, I think, 10 years to release the paper. And then it took another 5 to 6 years to really implement that particular thing. And then they keep on releasing the new trained models. Wherever they get the data, they go and then train the model and then they give that particular model. They call it as there is a context window where it can understand what has been asked earlier. There are tokens. Every text that you pass, every word can be a token. I don't think every word is exactly a token. There is a separate formula for that. You say that unbelievable is a word. Generally, the general formula is every 4 letters they consider. Sometimes, yeah, even more than 4 letters also. Again, there is an algorithm for that. But unbelievable would become, I think, three tokens. Un is one token. Believe is one token. Able, believable, able would be another token. Okay. Token is not just a word. Token is how a token is decided. It purely depends on, again, the mathematical algorithm internally they use. It might be part of transformer as well, or even before the transformer, it could be part of actually the embedding model as well. So you understand what is called LLM. LLM does a lot of work. Okay, whatever we see LLMs, they have spent billions and billions of dollars to train these data, billions of parameters of data that captured from various open sources, maybe archived files, as I said earlier, Wikipedia's archived files, white papers, uh, IEEE papers. I mean, if it is actually technological documentation, newspapers which are widely available. Okay, open source books, open source projects like that. They have captured the information wherever they get it from, and then they trained it. They trained it. So the basic algorithm of this LLM is this is the most important part actually. If you are in a training, we will discuss very deep about it. Mathematically, how they do is also we will definitely know about it. So there is a uh, transformer paradigm. Okay. So what actually happened? Transformer paradigm is earlier. What happened is it used to work on recurrent neural networks. Recurrent network is more of a programmatical way of doing things. Okay, recurrent neural network has lot of difficulties in understand. Okay, let's say that uh, Jiten wants to ride a car. Okay, what does he writes? What does he write, for example? So the neural network, when you say that Jiten wants to ride a car, what does what he refers to Jiten? Writes. What does he write? He writes a car. Right. If you really look at the full sentence, you understand the transformer architect would go back and then come back, the recurrent neural network kind of a thing. And then it is really very, very difficult to understand that what he refers to, what he writes refers to, and all. This is where exactly the white paper, something like attention is, the thesis, what is called attention is all you need has worked. Attention is all you need, work on the query, the key and the value. All these query, key and value would work on multiple layers of the transformers. Okay. It's actually they call it as a multi-head attention. Multi-head attention means it's not one head. They keep on running this particular Q key and value kind of an algorithm. Actually, attention. What query? What is the query? What is the key in that query? And what is the value that has to be evaluated from that particular query? All three of them. In fact, all three of them are three different vectors. The question belongs, let us say that particular question is split into three different vectors. Again, there is a soft math happens. There is a dot product happens. There is a cosine similarities happen. What has to come next? What he refers to? Are there any spelling mistakes in that? Like that, lot of layers of the transformer ultimately work on that, and then it go and then generate the text. What does he writes? Then the generator in the LLM uh, it go and then start generating that particular text. Okay. Jitin, yes, I know Jitin. Maybe. Yes, I know Jitin. You are Jitin. You like to ride the car. Okay. You are very much fascinated about the car. You might be having two or three cars. You shared your experience from the context, whatever we have typed earlier. Lot of information is gathered and then generated. Everything is based on the same thing, which is called LLM, transformer, LLM. Attention is all you need kind of an algorithm. Internally, it works on matrices, vectors, some kind of a cosine similarities. Okay. And ultimately, it's all about the prediction. Ultimately, what it has to predict, every new token it generates, it is nothing but what the next word that it has to predict. It's like a loop. It will keep on running until it feels that there is nothing to predict. Most probably, if it is a text, it would end with a full stop. It is a code, then it can understand that where to end the code based on what kind of a code you are writing. Okay, this is what exactly the attention is all you need. And the next thing is people started generating a lot of text using GPTs and all, but GPTs are a generalized data. As I said earlier, GPTs are all about how do you generate the data. Okay, I think I am audible, right?
Yes, yes.
Yes, sir.
Okay, thank you. Uh, GPTs are all about how you generate the data and all. But when you look at the organization, let us say that you are in a medical college. Okay, so you got to come to a medical college and then you come and then ask about uh, I want to know that who is the best doctor for maybe cardiology. I want to know that. For generally we don't go and ask in the medical college. I know that, but if you go to private college, let's say you go to Kim's, and then you go and then ask them, I want to know who is the doctor that is available on Sunday morning. Okay, who is the best doctor? For example, see, the world is changing. World is changing. People's requirements are also changing. It is not like people blindly go and then ask for a doctor. They can ask, the requirements are changing in such a way that people can go and then ask, I want to meet the best doctor in this organization. Right. That means the data that you are going to answer, or the GPT is going to answer, or a chatbot is going to answer, or even a representative or receptionist or something who's sitting there and then going to answer. It is not based on the chat GPT. It's not based on the OpenAI or Gemini. Because in order to know that who is the best doctor, the data is not coming from your Gemini or GPT. The data has to come from your local organizational data, which is pretty much private to the particular organization. Okay, because generally models are trained on the past data. Models are never trained on the current data. Whatever the models that we have, let us say that is it going to rain in Trivandrum today? What is going to be the temperature? Is it should I carry an umbrella? If you ask questions like that, so the model has no idea about today's data. But magically, the models are able to answer because the models are trained from such scenarios. Let us say that you go and ask her why the stock market has crashed today. Interestingly, a couple of years, 2 years ago, one of my relatives was sitting next to me. We went to a function. He was asking why the market is crashing today. I think 1.5 years ago. I told him, no, 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 brother, that it is not going to give you the data. He says that no, 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 GPT gives. Then it was my realization that GPT also started, doing the retrieval augmented generation. It is not only your organizational data. So far, that I used to think that only it used to give only the your organization. In fact, I worked on this area. Still, I had a feeling that GPTs can give only the previous data, but GPTs are trained nowadays even to give that. Okay, is it gonna rain? today, it can understand that yes, today is the context. There is a transformer architecture. Today is the context. For rain, it has to go and then hit the weather endpoint. Okay, let me go. I don't have the details of today. Let me go and then hit the weather endpoint. Where is the weather app? It would go and then hit the weather app. It fetches the information. It generates the text based on that and then give you yes, it is going to work. It is going to rain today. The weather forecast is something like it's gonna be the very heavy rain in some parts of Trivandrum. So it is. I advise you to carry an umbrella. That kind of text would be generated by GPT. You know that it's all about, it's a very exclusive, I don't say exclusive, but very comprehensive information they give. It's not yes or no based on information. Anything you type it in GPTs, it tries to give the best information. How does it work? It works on a concept called retrieval augmented generation. How the retrieval augmented generation work on? Okay, so the general models, the responses are strictly in verified retrieved source packs rather than the parametric static phase, because all the parameters, what I said as billions of parameters, they are all trained on couple of years ago data, or they are all trained on the data not exactly, not till today. Must it depends on when they release the model. If the model is released a month ago, definitely they might have trained the model for a couple of months, and then at least you can think that the data that they fetch, the models can generate is at least 6 months. I'm still I know that what do you call running the model is not very expensive task. It's not a small thing. It is a very expensive task. These organizations are pouring actually millions and billions of amount money into just to train the models, right? So it has to eliminate hallucinations, and then it has to go to the private enterprise data, whether it's an enterprise data or it is obviously it's an enterprise data, private data. It belongs to an enterprise organization. It belongs to a hospital. It belongs to maybe IRCTC. You can see that, and then it should have the real-time knowledge. Real-time knowledge is what actually I am asking about. What is the rain case? How does it know? Because it has to hit the endpoint. So from where the data is coming, the data may come from your PDF documents. The data may come from the comments that are written by patients about the doctors in their review and feedback system. The data may come from maybe the LinkedIn post. The data may come from hitting a URL like the weather forecast can come and all. All these things work on a concept called retrieval augmented generation. RAG, we call it as. RAG is very important. uh, the way how RAG works is there are again vector database, there are embeddings, there are again tokens. There is a little bit of embedding models run behind that. It generates the proper question. It pulls the data from the source. The source could be your PDF documents, which are generally stored like chunks. Okay, like chunks. Okay, let us say that what is the can you tell me what are the user stories, or you can say that what is the reviews of Faith Infotech? So when you go to the reviews of Faith Infotech, many people wrote, I think they wrote very good reviews about Faith Infotech, right? So Faith Infotech reviews may be public private data. It belongs to Faith Infotech Academy. What it does is it goes to Infotech Academy, go to their review systems, okay, review systems and feedback systems. It pull the data, it again feed it to your LLM along with the data that has fed by your internal system. It generates the data and then it gives the data. That's what retrieval augmented generation. Again, there is a lot of mathematics involved in that. There are a couple of systems involved in that. There are a couple of tools involved in that. Maybe you may have to hit an endpoint like a weather forecast, or you may have to hit an endpoint where it is a database of. Can you tell me how many students have studied in Faith Infotech from the year, let us say from 2020 to 2025? Assume that there are 4,000 or 5,000 students have studied in Faith Infotech. So where does it get the data? It has to go and hit from the database. So retrieval augmented generation is a pretty complicated concept in terms of data ingestion, and then the ingested data. Data ingestion means where are you feeding the data from? what kind of data you feed, and what are the tools that you need to use in order to fix the data. Is it an API endpoint or it is a database, etc.? And how you got to bring that particular data from the database. Everything we call it as a retrieval augmented generation to kind of a technology. That we will go and then discuss very in depth in this particular training. This is a basic end-to-end architecture of the RAG. Ingestion is nothing but inserting the data, ingesting the data into the system because it's a private data. It could be in a database, it could be in a website or a private website, or it could be a PDF documents, etc. We call it as a chunking the data because all the PDF document we don't put it into one vector. So what we do is we call it as a chunks. So relevant data we keep it as a separate chunks. Okay, generally chunks are maybe 4 KB chunks, 8 KB chunks. It depends on actually again data to data, organization to organization, and all. But ultimately we chunking. The concept is called chunking. Ingestion is a concept. Chunking is a concept. Vector embedding is a concept. How do you the chunks are converted into again high dimensional vector spaces via embedding models. There are separate models that would go and then run and then making as a embedding models where it would go and then store as tokens again into the vector database. And again, the vector search, the search is maybe cosine search. Cosine search. Cosine is that cost function. It applies some kind of a cost related functions mathematically and then go and then look at the nearest data that is relevant for this particular question, and it goes and then pull the data and then it feed the data again to the it feed the data as a query along with the data along with the context as a query to the LLM. LLM would all look into the entire data that is fed from the chunks and it frames the data. It generates a nice text. Let's say the same question: how many folks have studied okay, in Faith in Protect, for example, from 2005 to, for example, 2020 to 2025, it has to go and then search from the Faith in Protect database. Again, it only depends on if they are willing to, the system is willing to access the private data. Okay, certain data they give, certain data they don't give. Let's say how much fees that people have paid for that, no one gives. It's pretty much data that nobody would like to share, right? So it depends on it's all again the engineering you need to do. It's not like see the systems are pretty free to operate on, but it is the responsibility. You may say that where everything is done by the AI. So where exactly a person, where is my job? What is my job in this particular thing? Yes, your job is there to understand, to mitigate the system, okay, or to drive the system in such a way that ultimately human has to take a have a look into that and then drive that particular engineering. AI can generate, AI can pull, tools can pull, etc. But ultimately it's the human. What data to be given, what data should not be given. All these things we call it as a guardrails. Okay, particularly what should be done, what are the rules in order to pick the data. Okay, you are picking the information from a student. You should not pick the information of the student how much fees he has paid. It's pretty much confidential between the student and the academy, right? So these kind of things, what actually engineering, engineering means you may think that okay, this is just a this is not engineering job, this is more of a the laborious job. You go, no, it is not like that. You are not dealing with the data that is not in Excel sheet data. You are dealing with data that is ultimately in terabytes or petabytes of data. Okay. Ultimately, organizations are running AI models and then implementing RAG is not actually 100 records or 200 records. They're gonna run RAG on terabytes and petabytes of data in order to manage terabytes and petabytes of data. Your ingestion, that means how do you feed the data, should you need to have a lot of tools to be known. Okay, you need to know that how to work with data processing. You need to know how to work with batch processing or stream processing. Okay, Splunk data, for example, Spark data, where the data is, data processing pipelines you have to build, and that's a pretty big engineering task. It is not an Excel data to bring 100 or 200 records. For that, yes, you may go and then do that, but it is not the Excel data. Why do you store data in SQL? Okay, why don't you store data in Excel and think it as a database? The reason is Excel has got limitations. SQL is pretty good for the reporting purpose. Similarly, when you bring engineering practices into the RAG or AI based stuff, you need to bring full-fledged engineering discipline into this. The reason is a lot of things involved in that. A lot of things are involved in that. Okay. So obviously, the next step is it is not about just what is RAG, but you need to bring some kind of a orchestration kind of a orchestrator into the entire framework. That particular orchestrator is one of the orchestrator is called as LangChain. LangChain is an orchestrator. What is called LangChain? LangChain is kind of a framework that you use most probably using Python. Why I said most probably is there are other programming languages also evolving. Python has got its own limitations with respect to the memory consumption or compute consumption, etc. But generally, 90% or 95% people use Python. LangChain is one of the orchestration framework that is part of general Python libraries. This particular LangChain is one of the steps that you really make agentic AI. The first step of agentic AI is bringing RAG into the system. The next thing is start using some frameworks like a LangChain. The best example is weather report. Weather report is the best example. Okay, weather report is the best example because there is a unified model interfaces because we have models like OpenAI, Anthropic, Hugging Face. There are different kind of llamas are available, etc. All these models using LangChain, you can see each model has got its own kind of an interface. Their APIs are different. Okay, their interfaces are different. The way how they respond to the user is different. So unified model has been brought by LangChain. That means you ask a question in LangChain, through LangChain. LangChain has got the capability to ask the question across multiple LLMs. It could be local LLMs, or it could be local LLM means the LLM that you are running inside your own organization machine, or it could be OpenAI, it could be Claude, it could be Hugging Face models you got to run, etc. Like that, it's they bring a unified model. Okay, and one more thing is composable chains. Composable chains means how do you really write the prompts? What kind of models you got to use? What are the parsers? Because there is a concept called templating. Okay, templating means they would replace every time you ask a question to the AI. Sometimes what happened is, let us say that I ask a question. Okay, how many goals that Messi has made in the last FIFA World Cup? So Messi is the name of a player, right? You can ask another question that how many goals that Ronaldo made in this FIFA. So what is the parameter here? Messi and Ronaldo are two different names, two different players. So what could be the template is here? For example, I'm telling you, Messi and then Ronaldo, it become a parameter because the line chain kind of a frameworks are capable of just replacing the name but keeping the question, the query as it is. They write it as a parameter, which we call it as a templating tools. So composable chains means the connects prompts, models, output parsers, and external tools. External tools, as I said earlier, it may have to go to the FIFA World Cup and then grab the data. FIFA World Cup website is an external tool, or it may have to go to, obviously, it has to go to the authorized tools and then pull the data. It cannot go and then to different systems and pull the data. It has to go to the authorized tool. How do you know that what is the authorized tool to pull the data about Messi and Ronaldo? Obviously, you get to know because Messi and Ronaldo are the players, and then you need to go to FIFA World Cup, which is the which we can think it as a legitimate or correct data, rather than going and then surfing through different fetching from different newspapers, right? So composable chains are like this. You involve some tools. What is the tool here? Scraping data from their website. Sometimes you may have the access. Sometimes you may have to pay in order to get the access to their system, right? These kind of things are part of your line chain. Okay, LangChain has got a very rich tools ecosystem because you got to use it into Python. Ultimately, whenever you use Python, you can scrape data from your web pages. You can hit the endpoints and scrape data. You can talk to databases of various types. You can speak to systems, something like Kafka, etc. These kind of things, a rich ecosystem tool system is there. Memory abstractions means there is a concept that when you ask a question, most of the LLMs they have their own context windows we discussed earlier. But when you are going to diversify your LLMs from by using a unified model interface by using LangChain, you may have to store the context not in that particular LLM, but by using your LangChain memory abstraction. It can manage the chat. You say that it's a chatbot. You go and then say that hi, hi. It says hi. How are you doing? What is your name? I said that Jitin. My name is Jitin. How are you doing? I know that still it is a chatbot, but humans are with emotions. I say how are you doing back, for example. So the next context onwards, irrespective of which LLM is going to be connected, it would go start telling you that, hi Jitin, how are you doing? Next time you come to the same tab, chat window, it can say, hi Jitin, how are you doing for today? It can understand the conversation. How can it understand the conversation? Because everything gets stored in some memory. So this line chain has got the memory windowing capabilities, storage capabilities, persistent capabilities, so that you can all configure using LangChain. Okay, but there are some limitations with LangChain as well. LangChain is kind of, let's say that I go and then ask some details. For example, can you tell me? So I just asked a question. So is it safe now for me to travel to Ladakh, for example? You ask a question, is it safe to travel to Ladakh, for example? Why would you say? Because it's a rainy season. We don't know. There may be floods. There may be. I still I don't know what is about the conditions of Ladakh. I'm just telling you an example. What it does is it goes to the Ladakh related website, whether it could be a weather website or multiple website sites, and tries to hit the website. It fails. When it fails, the lang chain cannot do anything. When it fails, the line chain cannot do anything. What it says that unfortunately, I could not get any information about Ladakh, but if you want, I can go and then fetch the information from my previous records. It would go and then maybe it might go and then fetch the information that according to the same year, say same month, this time, last couple of years, what I can summarize is there is a moderate to heavy rain in Ladakh, so it is not always safe. Some information it generates from its history. But what happened is it is unable to pull the data of the current thing. What happened? It could give the data which is not relevant to you because you are asking for today's data, not about some time ago data. These kind of scenarios where LandGraph come into the picture, it's an excellent concept. The entire agentic AI, most of the part you would be using LandGraph. What LandGraph can do is it tries to hit the API. If the API is not available, it is kind of a loop. So when you hits the API, what would happen? There is a yes or no kind of answer. Success or failure are two scenarios. If it is success, yes, it pulls the information and gives your LLM. LLM will generate on top of that. If it is failure, it cannot pull any information. But LandGraph, what it does is it repeatedly tries to hit different sites. You may ask me a question. You may ask a question. How does it know to hit the site? Obviously, you need to give the information because these are the tools and these are the systems. Your system should have the connectivity to them. But it retries. That's the wonderful thing about it. It retries with the same system. Maybe weather system is too busy, for example. Maybe there is an alternate weather system you give access to. Or even though it is too busy, it can understand that, okay, let me go and then hit it once again. That is a kind of a loop actually. Okay. It is kind of a loop. That particular kind of a loop it can does, and then even it works until the system is successful. That is the specialty of LangGraph, which is lacking in LangChain. Obviously, these are all evolved step by step. Okay, tomorrow today there is MCP. Okay, people are using MCP as well. How do you go and then connect to different systems? Okay, tomorrow there will be other technology evolved. It's pretty much cumulative to what has been in the system right now. It starts with machine learning algorithms, turn into something else, turn into RNNs, turn into attention is all I need, and then turn into full-fledged LLMs. Then not one LLM, but multiple LLMs. Not one tool. It went into a RAG kind of implementation, and then now it is not only the RAG, not only the lang chain, but also RAG graph, where what it does is it would go and then fetch the information from various systems. It fetches the information until it is succeeded in order to fetch the information. Okay, and not only that, there is something called checkpoint. Okay, there is something, it's all orchestration. Orchestration is a concept that there is an orchestrator. That orchestrator would ensure that whatever you asked is, whatever you told is being done, whatever you ask is being done. That is the responsibility of an orchestrator. There are two kinds of orchestrators. One is called LangChain and the other one is called LangGraph. We discussed about LangChain. We also discussed about the limitations of LangChain. The other thing is called LangGraph, which is much more beyond the linear chains because the chains may fail. There is a concept called checkpoint. Checkpoint is something like the chain is failed at step number 3. Let us say that it went and then understand the weather information from one website. It is trying to check the weather information from other website, but it failed at the second website. Assume that it's a chain of things, actions. We call it as a nodes. So each action that it performs, we call it as a node. One node it has done, second node it failed, for example. The checkpoint is nothing but it is already done with the first node or a couple of nodes. It failed only at, assume that it failed only at node 5. Checkpoint is something like it would not start from the beginning. It can understand that it failed after node 4. So let me go and then get the information, whatever I have got from node 4, and then continue from node 5 onwards. Okay, these kind of things, it's kind of a loop. It can understand it's a success or failure. These kind of things are really done by LangGraph. LangGraph is like exactly the very much advanced step of agentic AI. Most of the stuff that people do with agentic AI is most probably with LangGraph. Okay, so the core principles of LangGraph, these are called nodes. Generally, nodes are nothing but the steps. Connecting to a system is a node. Fetching data from the database is a node. Okay, or compiling an application could be a node because you got to use the tools inside that. Each step that you perform inside is called a node. There is also called edges. Edges is the connectivity between one node to the other node. Okay, and then checkpoints is something. Checkpoint is something that between the edges it stores the state, and then it can decide where to go to the next step, which we call it as a conditional routing. Okay, it tries to understand your question. It failed to fetch the data from website 1. It failed, then there is the next step, which is called a conditional routing, that the next node would try to fetch the data from other website. Let's say both of them are failed, it tries to repeat. How long it would repeat? Definitely nothing would repeat for unlimited amount of time, unlimited times. Because unnecessarily it would go and then consume all your computation. How long it would repeat? Yes, it would be. It depends on what you write. Try for 4 times, try for 5 times. After that, ask the user, okay, to allow or to stop. These kind of things are part of actually the LangGraph, and also let the user to decide, also part of LangChain as well. Okay, and then what are the data that is to be stored between the nodes and the edges? There is a persistent storage. Okay, type deck or even Pydantic is kind of a uh, 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 thing across the node. The data can be stored into the system. Okay, So there is another framework called React Pattern. React Pattern is actually part of the same part of LangGraph. Whatever I am talking about LangGraph, people use the framework something called React Pattern. React, reason to act, reason plus act is called React. Okay. There are two kinds of things we generally talk about. Cyclic chain. Cyclic chain means one after the cyclic chain means it's a kind of a cycle. LangGraph is a cyclic chain. There is acyclic chain. Acyclic chain means if a chain is something is failed, which is done by lang chain, that's it. It would not execute. It says that it's a simple thing. If you are a coder, you might have come across a lot of things. You compile your application. You say that give me a Java application or a Python application to perform CRUD operations. Okay, for a employee management system. You get the code. You execute the code. It fails. What do? You copy paste the code again. How long? And it gives you some kind of a solution. Sometimes it say that unfortunately I generated the code, but I could not compile because compilation is beyond my task. Again, you paste the code until it is successful, right? That is nothing but LangChain, LangGraph. Until successful, what do you do? That is nothing but React pattern. Okay, there is a loop. Okay, you add some kind of a tool capabilities. Okay, maybe the inject. These are all actually JSON kind of a configurations, most probably. Okay, you add a tool like something like a Java compiler. You add a tool something like a Spring Boot packaging system. You add a tool like Sonar Cube, kind of a generating the statistics, or Jacopo kind of a thing, verifying that particular your tests. If you are a technologist, you understand basically these things. So what do? You keep on pasting inside your chat GPT or a Gemini or a Claude until you get the correct response or a result. Even you want a presentation or you want to generate an image, if you are not satisfied with the image, which is not actually according to your requirement, what do? You keep on asking it. That keep on asking and trying to regenerate until it is successful is nothing but LangGraph. React is kind of a pattern in order to execute the LangGraph. That's what we go through the examples and then we will discuss all these things uh, uh, in this kind of a thing. Okay, so these kind of a things we discuss about the architecture and go through in depth of all these things. Whatever we are discussing, I'm trying to speak little fast so that I would like to give you some kind of an overview about all the things. Uh, there are different architecture patterns. There is a flow control. There is where the state is actually persistently stored. Something is stateless, something is stateful. Okay, what are the best use cases for using each and everything? What is the best use case to you just use the LLM like a ChatGPT? What is the best use case to use a rack system or LangChain? What is the best use case to write completely an agentic AI, which would run or act as a test engineer, which would act as a manager, which connect to your Jira tickets? Everything we will discuss into this. Okay, so that's what about the demo. Sorry for taking additional time. This is what actually the webinar is all about. You have any questions, you feel free to ask.
Okay, guys, thank you so much, Jitin. It's a QA session over here. Guys, please pull in your questions over here, and Jitin will be there to help me. Please. And also, there is a form in the chat. Participants, please fill that form to understand how we can have the sessions. Okay, please fill in the chat. In the chat, we have put it over there. Open to you, to each and everyone, for the question and answer session.
I'm sorry, I switched off the video because of bandwidth. When I found it, actually, there is some glitch in the voice. I thought I have to save the bandwidth. Yes.
Any questions from your side, each and every part? Also, can you fill in the form?
Yeah, just wanted to, get some opinion. If we want to build a strong foundation, any online basic courses that we can go through I think some of your concepts in the presentation, I mean, were good to hear. But I think a little more basics in our own times probably might be easier to understand. So, do you
Yes.
recommend any courses that we can go through? Can you share the link on the chat?
Um, the only one course is once upon a time it was you need to learn. I'll tell you, it's a elaborated answer. Once upon a time, you need to learn the basics of mathematics. You need to be very strong foundation in mathematics, and then slowly you understand couple of data ingestion techniques where the data is coming. Strong foundation in SQL, strong foundation in maybe Kafka kind of a thing. But if the current trend, the technology is so fast paced actually whatever we learn today, it would become a little bit of. I'm talking about the basics. It could become irrelevant, maybe by within 4 to 5 6 months. So what I always say is get some foundations in Python. That is the only thing. For this course, you need to get foundations in Python and the basic Python fundamentals. You know how you should be able to use a package that is written in Python. You should be able to use. Go and then pick the package and then starting using it. Still, that also we will cover in first 1 or 2 hours of the training. But that is what, if you know that, I feel that you are good to go. Okay, that is the first thing. If you're too much curious about, obviously, every one of us is very curious about learning from the very much foundations. But how much time we have is also very important. Some of us will have time, some of us may be. So go through little bit of elementary mathematics, at least understand that cos function, sine function, kind of a thing. Go to the little bit of uh, y equal to mx plus c function, as that is the foundation of the entire machine learning and ultimately the agentic AI. And little bit understand about the matrices. That also we have a plan. I think Sanuji, we plan to cover that as well, right? In this training,
Yes,
the
yes,
basic
yes, yes,
foundation.
yes, yeah.
Yeah, but still, if you can spend little time on that, because we got to cover in 2 hours or so, I think it's good thing so that you understand actually things work. Without that, also, I mean, I tell you, without knowing anything, also there are people who are able to run agents, who are able to create agents. But I don't prefer that way. Know some programming fundamentals, know a little bit of mathematics at least. It's not always about executing things. In order to do proper engineering, sometimes you need to know how things work as well. Sometimes, like, you may have to compare which is the best tool. Okay, what one thing, you need to know some models, basics of models. So these things we will explain. Still, if you can spend little time on foundations of Python and little bit of mathematics, I think it is sufficient.
Do you have like a structured kind of a plan before we start your program? Like, is there a like a checklist of like video tutorials that you recommend that we run through, which kind of endorses our understanding on this max and little bit of Python? So that might help, if you already have that plan with you.
I right now, I don't have the document, but Sanuji will, for sure, he will provide you that document.
Okay.
No issues. I will give you some references, materials. Uh, I know that what is required. If not, actually, I'll create and provide you. There is no problem at all. And then obviously the YouTube links. There are pretty good links in YouTube. Uh, Ours is more of a doing kind of a program than a more of most of the theory. We try to do as much as possible. 80%, unless until it's purely a theory based stuff like understanding certain things, but mostly it's a doing thing. So most probably, uh, I mean, he will share with you. I will provide him and then he'll share with you.
Sure, for example, whatever Jitin is sharing with me, I will surely share with you, and you will get an idea, and you will be having the time to go through it also, because our session is going to happen in September now, because this month actually the Onam seasons are going on, so mostly all the companies are electing to send their representatives. So basically, we'll be starting in by September 12th. That is the date that we'll be fitting in. We are planning actually the sessions like on a Friday, Saturday, and Sunday. I think we have shared one form with you. I need everyone's opinion on this, because we will get an opinion whether we should do it in 2 weeks like in Friday, Saturday, Sunday, from morning 9 a.m. to 5 p.m. at our premises in Faith Infotech in Technopark. Or else, if you want to do it in online, also we are happy to do it also, because mostly like it is taking a good number of time. So most of the people were asking these suggestions. Over here, I have just created one Google form and shared in the chat. Please take your time to just tell us how the best we need a session. We all invite you to our premises also to have the session. Otherwise, we shall have it on a Saturday, Sunday. That is 3 weekends. In 3 weekends from morning 9:30 to 5 p.m. in the evening. That is what we are planning, because mostly it's a hands-on session that will be going through. Taking to a hands-on session. It is theory will be there, but a little bit, but completely not doing the work, right?
Yeah. It's a hands-on session. Yes. 80%, 80% we do, and mostly 20% wherever it's as and where required, we go and then try to understand things. Mostly it is hands-on session.
Any other questions from your side, please? We have some minutes more.
Sorry, remind the dates of the program. Is supposed to start from this week or next week?
No, actually, in August, the training program is shifted to September. Actually,
September.
yeah.
Oh, okay.
Because of the Onam. Yes, that basically all the people have on a vacation, and all the companies are having their Onam celebrations and everything. So they shifted a bit a month ahead, like postponed it to September, and start by 12. That is some of the suggestions came up from different organizations in Technopark.
Okay.
Any other questions? Okay, can we wind up the session? All right, please fill in the forms over there in the meet. I have that chat and shared in the chat also. So please fill in your responses. I appreciate. Okay, everyone, thank you so much for your time. And Jitin, especially, thank you so much. A great job. I hope that the session was a lot of information was passed to each and every one. So we will be sharing all the other informations accordingly with regarding to the start of the batch and date and time and everything. And thank you so much. Enjoy your weekend. And this is Sanil Jacob signing off. Thank you so much. Take care.
Thank you. Thank you
Thank
much.
you, everyone. Bye-bye.